Hello, it's Mrs. Geoscience here and welcome to my video all about energy transfers. Now this is for the paper 1 part of your topic, so the energy transfers scenario is actually touched upon quite lightly in the first part of paper 1, but it is the basis for your entire course. So we start the course with an introduction to energy, and then we have this concept of energy stores, which you would have seen my previous video on energy stores. So we've got your gravitational potential, kinetic, elastic, thermal, etc. But your energy transfers talks about transferring energy between these stores. Now, before I go on to talk about those energy transfers, it's really important we understand this crucial law, which is the conservation of energy law. Okay, and the conservation of energy law states that energy cannot be created or destroyed. Cannot be created or destroyed. That is the conservation of energy law, but we tend to tag on another sentence, which is that it can only be transferred from one store to another. Spelling another. Now, your specification actually lists some very key energy transfers that it wants you to know about, and in my next video I'm going to describe those energy transfers and take you through those examples, because those are the ones that are likely to come up on your exam. For today though, we're just going to learn about these 4 ways of transferring energy between those 8 stores that we learnt before. So the first way of transferring energy is energy transfer by heating. Okay, and energy transfer by heating involves our 3 ways of heating, which are conduction, which is when thermal energy is passed between objects that are touching each other, convection, and that's when thermal energy is transferred by particles in a fluid moving, and then we have radiation, and that is thermal energy that's given off all objects. We do that later on in the waves topic, and that we talk about infrared radiation, and we talk about good emitters and absorbers. Okay, but thermal energy is really key. So when you learn first about the energy stores, you then go on to learn about energy transfer by heating, and you do the required practical associated with specific heat capacity. Okay. So that's a required practical, and you learn about this equation in more detail. So the energy equals mass times specific heat capacity times the change in the temperature, and specific heat capacity, the definition of, is the energy needed to change the temperature of 1 kilogram of a substance by 1 degree C. So that is heating. You then go on to learn about how we get energy from fossil fuels into our home, or how we get energy at all into our homes. So that uses heating. So pretty much any old-fashioned way of generating electricity uses heating. You would burn a fossil fuel, which would heat up a fluid, giving convection, and that would cause a turbine to turn. So that's thermal energy going into kinetic energy, causing that turbine to turn. It turns a magnet, which in turn generates electricity. So the second way of transferring energy then is electrical. And so that is about transferring energy by uneven charges, shall we say, and we call that, more correctly, we'll call that potential difference. So by creating a potential difference we've got uneven charges or energy used to drive charge around a circuit, yeah? Okay, the third method of energy transfer then is mechanical. So let me just go back a second, because we've done energy stores, we've done conservation of energy, we've done energy transfer by heating, and we've done energy transfer by electrical means. We've then gone on to learn all about electrical circuits in the home and electricity in the home. There are 2 required practicals in this part of the course, which is resistance in the length of a wire and then the one about components, yeah, so resistance in various components. I think it's called component characteristics, okay. So that's paper 1 kind of done in terms of energy. Then we move on to mechanical. So mechanical is any energy transfer associated with forces, okay. And you will notice that the first part of paper 2 is all about forces. This is also, this is a whole branch of physics we call mechanics. We might also call it Newtonian physics, because you learn about Newton's 3 laws. So the law of inertia, the F equals ma, and the equal and every action causes an equal and opposite reaction. So that is really the first part of paper 2, isn't it? And you've got a few required practicals in there. So we've got our extension on a spring, yeah. And you've got the light gate one, so the F equals ma one. Okay, and then finally, the last way of transferring energy is by waves, okay? So that's the second part of paper 2, and you learn about waves, and the first thing you learn is that waves transfer energy and information. Now, energy transfer by waves is sometimes known as energy transfer by radiation, okay, because it goes out in all directions. But our typical examples of energy transferred by waves are light and sound. So my guess is that as you were learning energy in physics GCSE, and you were asked to list energy stores, or even you had many questions on energy stores, you would at some point have said light or sound as an energy store. But because the way your course is laid out, AQA wants you to determine light and sound as an energy transfer by waves. And you do learn all about sound waves and light waves in your course. The light waves, of course, are learnt when you do the electromagnetic spectrum. Okay, so that's my video on energy transfers. You can see that it gives you almost all of your course. The only parts of your course we've not spoken about is the particle model and the radioactivity. So your particle model of matter really speaks to concepts in chemical energy, and your radioactivity, of course, speaks to the concepts in nuclear energy.